Now, we are continuing with the stationary waves. The first part of the stationary wave, that is vibration in a stretched string. Just now I have mentioned that in this case the transverse stationary waves are formed in a stretched string. What happens? There is a string stretched, it has a tension capital T suppose, and a string of length L is stretched here between the two rigid supports. And what happens? If the string is plugged in the middle and released, it will start vibrating. If it is plugged in the middle and released, it starts vibrating, forming one loop like this. It is forming a loop. What happens? Why this loop is formed? Because a stationary wave is formed. This is the positive direction, this is the negative direction. Other modes are also there. It may vibrate, forming 2 loops, 3 loops, and so on. But what happens? Due to the formation of the stationary waves, here this is a transverse, suppose a transverse longitudinal transverse traveling wave. It goes like this and it is reflected back. Like this it goes in the positive x direction, negative x direction is coming. Fine. What happens here? Just see a very important thing. It is reflected by a fixed boundary. It is reflected by a fixed boundary. So it goes like this, but it comes back in the opposite direction. That means it is the case of phase reversal. Very important thing. It's a case of phase reversal. ये जा रहा है ऐसे, वापस आ रहा है opposite. फेज रिवर्सल हो रहा है. कब फेज रिवर्सल होता है? जब क्लोज बाउंड्री पर जाकर के हिट करता है और वो फिर रिफ्लेक्ट करता है. ठीक है, तो यहां पर क्लोज बाउंड्री, दैट्स व्हाई फेज रिवर्सल इज टेकिंग प्लेस. ओके, सो आई राइट हियर, लेट द इंसिडेंट एंड reflected waves are given by y1 is equal to r sine twice pi by lambda vt minus x. I hope all of you are remembering vt minus x. It goes positive direction. Okay, positive x direction. And reflected one y2 is equal to minus r sine twice pi by lambda vt plus x. This minus sign, right? I can say here this minus sign is due to the phase reversal. Okay, here negative sign before r. Okay, shows phase reversal. जो मैंने तुम्हें बताया था सुपरपोजिशन प्रिंसिपल के समय ध्यान रखना होगा, फेज रिवर्सल हो रहा है कि नहीं, उसी के अनुसार दैट विल बी एडेड. सो बाय सुपरपोजिशन प्रिंसिपल resultant displacement is y is equal to y vector is equal to y1 vector plus y2 vector. So y is equal to y1 will be r sine twice pi by lambda vt minus x plus here with negative sign r sine twice pi by lambda vt plus x. I hope, dear students, you have very easily understood why we are writing it like this. Then it will be r will be taken common, sine twice pi by lambda vt minus x minus sine twice pi by lambda vt plus x. A small bit of mathematics is needed, so I hope that much mathematics all of you know. I write r, and here it is sin c minus sin t. I write here for your reference, sin C minus sin D, sin C minus sin D is equal to 2 cos C plus D by 2 into sin C minus D by 2. I hope you all are agreed with this. 2 cos C plus D by 2 into sin C minus D by 2, 2 cos twice pi by lambda Vt minus x plus Vt plus x by 2. Look, just according to that formula. Into sine twice pi by lambda Vt minus x minus Vt minus x by 2. Just to please check what you are getting. Twice r cos twice pi by lambda. Here see only Vt into sine twice pi by lambda into x. Here sorry minus x. Here it is C. You are getting it minus x. It's alright. I hope all of you are agreed to this. Minus x, because here see x and x cancels, here Vt and Vt cancels, minus x, and here we can write y is equal to sine minus theta is minus sine theta. Okay, I write here minus twice r cos twice pi by lambda into Vt into sine twice pi x by lambda. I write here as sine of minus theta is minus sine theta. It should be remembered, sine of minus theta is minus sine theta. Here minus sine will appear, which is coming here. This is the, just identify this. This is the equation of a stationary wave. I think you can very easily distinguish between the stationary wave and traveling wave. In NCERT, there are questions. You have to identify whether the given equation is the equation of the stationary wave or is it traveling wave. जब भी stationary wave का equation होगा, उसमें देखोगे अलग से separately t का expression, separately x का expression, like this, separated. But here it is here together Vt minus x, Vt plus x. These two are for the traveling wave. These two are for the progressive wave. Progressive wave is also called traveling wave. But stationary waves दोनों अलग अलग, sin cos अलग, पहचानने में आसानी. Okay, this we are getting, no problem. Now I will apply boundary condition. Okay, let us now apply. Just try to follow how this boundary condition is applied. Boundary condition मतलब ये हुआ, always it will always be applied at the boundary. Boundary का मतलब कौन सा है? ये boundary है. याद रहे, हम लोग अपने discussion में, in our discussion, we shall always consider the point from where the reflection takes place as x is equal to 0. Okay, from where reflection takes place. I repeat, from where reflection is taking place, that is x is equal to 0. Definitely the other end is x is equal to L. Very clear. X is equal to 0. It is x is equal to L. Okay, fine it is. Let us apply boundary condition here. I will write at x is equal to 0. जब x 0 होगा तो sin 0 is 0, so y equal to 0. फाइन, ठीक है. जिस समय x का वैल्यू 0 है तो y का वैल्यू भी 0 है. ठीक है, यहाँ कोई डिस्प्लेसमेंट नहीं, क्योंकि यहाँ पर नोड बनेगा. द नोड्स आर हियर. एट द नोड्स देयर इज नो डिस्प्लेसमेंट, सो at nodes there is no displacement, so x is equal to 0, y is also equal to 0. Fine. Now at x is equal to L, कहाँ पर? यहाँ पर. Also y इज इक्वल टू 0, हम बोलेंगे कि हाँ भाई चलो x इज इक्वल टू l पर भी तो y का वैल्यू 0 है, क्योंकि यहां पर भी डिस्प्लेसमेंट नहीं है। तो इसका मतलब क्या होगा, इसका मतलब ये साइन यहां लिखेंगे, सो साइन ट्वाइस पाई l बाई लैम्डा शुड बी 0, और ये 0 कब हो सकता है, ट्वाइस पाई l बाई लैम्डा शुड बी n पाई, should be n pi, where n is equal to 1, 2, 3 and so on. इसका मतलब हुआ this cancels. What we are ultimately getting, lambda is equal to twice L by n. Look, what general expression we are getting? We are getting the same. Lambda is equal to twice L by n. Look, I am getting lambda is equal to twice L by n. Okay, fine. Now you must be remembering that we know that speed of transverse wave in a string, पढ़े हुए हम लोग, is v is equal to root t by m, where you know t is the tension in the string, look, t is the tension in the string and m is the mass per unit length of string. T is the tension in the string and m is the mass per unit length of the string. So what will happen? What is V? V is equal to कितना हो जाएगा? V is equal to कितना होगा? So frequency nu should be equal to how much? Frequency nu should be equal to V by lambda. V by lambda मतलब हो जाएगा, V by lambda का मतलब हो जाएगा V by twice L into N or n by twice the root t by n. Look, we are getting this expression. Frequency is equal to n by twice the root t by m. यही हमारा फाइनल एक्सप्रेशन हुआ, Look, और यहां पर n क्या है? n is representing the different modes. n का वैल्यू यहां पर 1 होगा, यहां पर 2 होगा, यहां पर 3 होगा, like this. As n will be increasing, okay, frequency will also be increasing. n का वैल्यू जैसे जैसे चेंज होगा, फ्रीक्वेंसी का वैल्यू भी वैसे ही वैसे चेंज होगा. Okay, here I can say for n is equal to 1, nu 1 is equal to 1 by twice L root t by m. ठीक है, इसको क्या कहा जाता है? दिस इज द, याद रहे n का वैल्यू मिनिमम कितना है? 1 by twice L root t by m. What is this called? This is called the first harmonic or fundamental frequency. इसे कहते हैं फर्स्ट हार्मोनिक और फंडामेंटल फ्रीक्वेंसी. ये फर्स्ट हार्मोनिक है या फंडामेंटल फ्रीक्वेंसी कहलाएगा. फंडामेंटल फ्रीक्वेंसी क्या है? मिनिमम फ्रीक्वेंसी obtained from this. Very good example of this vibration in the stretched string is there in a musical instrument like sitar, guitar, stringed musical instruments. Okay, so this is the first harmonic. एंड जैसे जैसे n का वैल्यू चेंज होता जाएगा, n का वैल्यू 2 तो सेकंड हार्मोनिक, n का वैल्यू 3 थर्ड हार्मोनिक, फोर्थ हार्मोनिक, ऐसे चलेगा. ओके, जस्ट यू गो थ्रू दिस. ओके, एंड आई होप द सिमिलर you just be prepared, because in the next class we shall discuss vibration in the organ pipe may be almost the similar equations will be used. All right, so please go through this